Alright, so let's get on to the Gauss elimination method. So the main difference between the Gauss elimination and the Gauss-Jordan method is that the Gauss-Jordan method actually converts the numbers above the diagonal and below the diagonal to zero. While this is not the case in Gauss elimination, as in Gauss elimination you only have to convert the numbers below the diagonal to zero, and the numbers above the diagonal, they don't really matter. You don't have to change them uh, or make any changes to them. So let's get into the working and the code of the Gauss elimination method. So how I've started this one is I've again defined the Gauss elimination function, and what this does is it iterates over the each row of the matrix to make sure it processes everything. And here with the partial pivoting, what the partial pivoting does is it finds the row with the maximum absolute value in the current column, and it swaps it with the current row. So after that, the making the diagonal element 1, as it is almost half of the part of the whole process. Half the part is making diagonals 1 and half the part is making the other 0, which in this case would be the ones below the diagonal. So what this does is makes the diagonal numbers to 1, and just in case the user inputs a matrix that is probably single dimensional or not more than one dimension, so this error will be previewed, so the user knows that he made a mistake in inputting, and he will probably reconsider his input. And after, what I have done here is make the other row 0. Now in the Gauss Jordan method, what this used to do, it used to make the number 0 above the diagonal and below the diagonal, but in this one it will only make the zeros below the diagonal. And getting into the next section is displaying the final matrix. So what this section does is, when the whole process is done, when the matrix has been changed towards a row echelon form, then this displays the matrix in its final form after it has been processed. And getting into the print solution, what the print solution does, it prints the solution, the values of variables from the last column of the matrix. And the last column of the matrix, the right hand side, which has the values, and if you write the values in a linear equation, the values would be on the right side of the is equals to. And after that, I have defined the main function, and what this does is, first it takes the input from the user, and it asks the user how many variables they want. And the variables, it means the dimensions basically, and they can enter 3, which will mean the matrix will be actually 4 by 3. So it will actually be 3 rows, but the columns will be 4, because the last column will not be counted in it, because it doesn't it is the solution, and it doesn't need to be changed, so it will not be counted in the process of the whole matrix. As there's no changes that need to be made to that, it will just flow along with the process. And after this, it is here's the augmented matrix that the user will have to input and give all the inputs of the matrix. And what I have done here is I have used a float data type, so the answer is more accurate, and it doesn't take the ground value or the ceiling value, and we get the exact answer in decimals and points. And after this, it is the perform Gauss elimination, and what this does is it just performs the whole method and processes the whole matrix. And what this one does, it just prints the solution. It is a function to print the solutions of the whole process. And again, this is here the value error, which prompts up an error if there is any error in the value, so the user knows to change their input. And in the end, this executes the main function if the script is ran as a main program. So it is just there to make sure the script runs perfect. And let's go ahead and do an example of this. So let's run this, and here the program is asking me the number of variables, so let's give it 4. Alright, and I'll just type anything. Alright, so that is one row, and just to make and that is one row. Yep. Alright, and there's a second row, that is the third row, that is the fourth row. Alright, so what I've done here is I've on purpose made an error in the input, because as I said, it's 4, but the rows will be 4, but the columns should be 5, as I explained in the code, that even if it's 3 by 3, it will actually be 4 by 3, because the last column doesn't count. So it gave us an error that out of range, as it doesn't match it. So we'll run it again, and this time let's again do 4, and we'll input a 5 by 4 matrix. So let's do this. This is 5. This is the second line, and let me just give anything as the input. Alright, and see, the program has executed, and these are the results. So as you can see that the diagonals here, 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 all these 4s are reduced to 1, and all these elements under the 1 under the diagonal are 0, and as you can see, the elements above the diagonal have not been alterated or made to 0. And the last column here, it will be the solutions, which here x1 is 11.5, x2 is -3, x3 is -4.6, and x4 is 1.616, and so on. So this was the solution for the Gauss elimination method, and I hope you understood it, and thank you.